This program has been brought to you by the National Science Foundation and by viewers like you. Thank you. For years, BBC and Planet Earth have ventured around the world, illustrating the vast diversity that this planet has to offer. However, they have overlooked one small thing: the small sand burrows of the frigid North Atlantic. Now watch as we take you on a journey into the hidden world of the fiddler crab to uncover their true secrets, thus optimizing the hidden wonders of the small arthropods which once seemed to be so common to us all. The fiddler crab, or Euca pugnux, spends most of its time burying itself in the coastal sands, typically along the North Atlantic seaboard. It is most characterized by its unusual and unique mating rituals, which male crabs carry out. The male crabs will first wave their claw high into the air, and then strike it down onto the sand. The combination of both the male waving its claw and then striking it, which creates a vibration, attract the female in mating season. The crabs typically mate along the spring tide cycle, as they use the tide cycle to carry out their mating needs. In a recent experiment conducted by BBC World and Planet Earth, scientists Lindsay Parton, Matty Childs, and Andrew Falaci conducted a field experiment where they researched the differences and the effects of sound vibrations in the environment on the mating behaviors of the crabs themselves. In the experiment, the crabs are first introduced to sound vibrations at 100 Hz. The frequency of this vibration is supposed to simulate the male crab's striking of the claw on the sand. Those vibrations are supposedly linked to the female's attraction. In the experiment, the researchers found that this was indeed true. As you can see, the frequency at this stage of the experiment is around 100 Hz, and the female is attracted to the male, going over to it. Later on in the experiment, however, when the frequency is raised to 250 Hz, the female and the male begin to separate. This separation is due to both the male and the female reacting negatively to the increase in the sound frequency. This would conclude that an increase in the sound frequency or vibrations in the environment would cause the crabs difficulty in continuing their natural mating behavior. When the frequency was raised to 1000 Hz, much higher than any normal environmental sound frequency, both the male and the female crab appeared stunned and separated drastically from each other. Here, just now as this video is recording, you can see that at 250 Hz, the male is beginning to separate itself from the female, and the female beginning to separate herself from the male. This shows there is dramatic confusion between both the male and the female. The information that the researchers gathered is critical for the future of the fiddler crab, or Eusa pugnix. The research indicates that the crabs do indeed have difficulty with an increase in sound vibrations. It is seen how this increase in sound vibrations dramatically affects their natural mating behavior. The behavior seems altered as the frequencies increase. This research suggests that an increase in the environmental sound frequency, such as the production of wind turbines which create a louder noise on an environmental basis, could indeed alter the natural behavior of the fiddler crab. That could dramatically affect the environment, as their natural behavior would be altered and the entire ecosystem could change as well. Thank you. From all of us at Planet Earth, and we want to thank you especially for helping us continue to make Planet Earth and BBC a continued success.